Hello, my dear students. Welcome to our channel motivus. Now we are in the sixth lecture of the chapter Some Basic Concept of Chemistry. Here we'll be discussing about the stoichiometry coefficient and how we have to apply more concept to find out the product formed if they have given you the initial amount of reactant and all the kind of questions regarding stoichiometry. Fine. First, you should understand what is a chemical reaction. It's a rearrangement of atoms. So, rearrangement of atoms is giving you a chemical reaction. So, we can say that in the reactants, there will be a lot of atoms. The atoms rearrange to give you a new product. This process of rearrangement of atom is what you are calling as chemical reaction. Then obviously the question comes, what is stoichiometry? It is a study of chemical reaction and the calculations relating to that one. Fine. If you go with one equation, SO2 plus O2 gives you SO3. If I ask you a question whether this reaction is balanced, no, because the number of reactants and the number of products should be same, or we can say that the mass of the reactant should be equal to the mass of product according to law of conservation of mass. Now you can see one sulfur, four oxygen on the left hand side, but only three oxygen on the right hand side. It is unbalanced equation. So can I balance like this? If I balance like this, you just imagine half O2. O2 is a molecule, it's a gas molecule. Whether half molecule exist? No, obviously half molecules won't exist. So it's a better way to represent it as 2SO2 plus O2 gives you 2SO3. This is actually somewhat more fundamentally correct balanced equation. Fine. So now this is a balanced equation, and this 2, 1, 2 that we have represented to balance the equation, we are calling it as stoichiometric coefficient. Stoichiometric coefficient. And this we can represent it as shortly SC, stoichiometric coefficient. Whether it represents the weight, like that 2 gram of sulfur dioxide reacting with 1 gram of oxygen to give you 2 gram of sulfur trioxide, whether it is true? No, it won't be true. Why? Because according to law of conservation mass, just now as I said, the mass of reactant should be equal to the mass of product. And here you can able to see that 2 gram plus 1 gram reactant is 3 grams already, but the product is only 2 grams. So the mass of reactant and mass of the product is not balanced. So it's a violation of conservation of mass. So just remember, if you got a balanced reaction, it does not represent the weight of the reactants and product. Then what else it represent? It represent the number of molecule. It can represent the number of moles. Like I can say 2 moles of SO2 reacting with 1 moles of O2 gives you 2 moles of SO3. Or I can say 2 molecules of SO2 reacting with 1 molecule of O2 gives you 2 molecule of SO3. This is how I can represent. Like you can able to see in this tabular column how many molecules: 2 molecules of SO2, 1 molecule of O2, 2 molecule of SO3. And how many atoms? 2 into S, 2 sulfur atoms, 2 into 2, 4 oxygen atoms will be there. Here 1 into 2, 2 oxygen atoms. And we have to represent the mass in AMU. Sulfur, 2 sulfurs are there, right? And you got 4 oxygen. The total mass of 1 sulfuric acid is 64. So how many molecules we got? 2 molecules. Molecular mass of sulfur dioxide is 64U, and you got 2 molecules of sulfur dioxide. So 2 into 64, 128. This is how the mass will come. If we talk about the molecules, I can write as 2 molecules of SO2 is present. So how many atoms? 2 mole S atoms, 4 mole oxygen atom. Again, if you represent the mass, then the mass should be in grams. So 128 gram. This is how the representation goes. Now, if you initially I was representing 1 gram, sorry, 2 gram plus 1 gram is equal to 2 gram. And I said it is wrong because it is violating the law of conservation mass. Whether this is violating, look at that, 128 plus 32, this gives you 160. Product is also 160. So mass of product and mass of reactant is same. So it is obeying law of conservation of mass. Fine. If you wanted to solve equations, questions relating to the small concept, the stoichiometry, we have to consider a reaction AA plus BB gives you Cc plus Dt. If they have given you a reaction, what you have to do is the small a, I am writing the stoichiometric coefficient, small a is the stoichiometric coefficient of A, small b is the stoichiometric coefficient of B, and small c is the stoichiometric coefficient of C, and small e is the stoichiometric coefficient of D. We have to apply mole concept into this equation. I can say that if this is a balanced chemical reaction, then I can say number of moles by stoichiometric coefficient of A should be equal to number of moles by stoichiometric coefficient of B, that should be equal to number of moles by stoichiometric coefficient of C, which is equal to number of moles by stoichiometric coefficient of D. I can apply this into equation. Limiting reagent concept will be dealing later. So if you get an equation like this, a balanced equation like this, so how you have to find out the answer for a particular question? Maybe they can ask you a question, number of moles of A, they have given you 10, and we wanted to find out the number of moles of B. How will we proceed? They have given us A, they are asking us about the B. So what you have to do is you have to equate these together. So number of moles of A by stoichiometric coefficient is equal to number of moles of B by stoichiometric coefficient. You have to equate and you can find out the answer. Let's say number of moles of A is 10. Stoichiometric coefficient of A is small a. So I can write that this can be 10 by A. And n of B, I don't know, that I have to find out. Stoichiometric coefficient of B is small b. So what will be the answer? NB is equal to 10B by A. This is how we can solve the equation, right? So we are analyzing what all these stoichiometric coefficients are representing. N2 plus 3H2 gives you 2NH3. This is a balanced equation. This 1, this 1, this 3, this 2. What these represent? 1 mole of nitrogen reacting with 3 moles of hydrogen. We can talk like that. Then at STP, if the condition is STP, we can say that 1 mole of a gas occupies 22.4 liters of volume. So this is 1 mole. We have represented as 1 mole, so it's fine. So we can write as 22.4 liters of nitrogen reacting with how many moles? 3 moles. So 3 into 22.4 moles of hydrogen, and you will be getting 2 into 22.4 moles of, sorry, 2 into 22.4 liters of ammonia. Then I can represent this one as volume, 1 liter, 1000 ml or 1 ml. So you can simply represent mole, molecules and volume, but you cannot represent the mass directly. Mass, 1 mole of a gas contain 28 grams. 3 moles of hydrogen contain 6 grams, because 1 hydrogen carries 2 grams. And this is, and 2 moles of ammonia mass is 17, 2 into 17, 34. So now this is according to the law of conservation of mass. 28 plus 6, 34, that is the mass of the product. Now, okay, fine. So now let's solve this question. Fine. If 28 gram of nitrogen react with hydrogen to form ammonia, what is the amount of ammonia formed? That is what the question is. Look at this. N2 react with H2 to form ammonia. First you have to write the equation. N2 plus 3H2 gives you 2NH3. Done. Which are all the stoichiometric coefficients? Let's say here 1, here 3, here 2. What they have given? They have given nitrogen. They have talked about nitrogen. And what they needed, amount of ammonia formed, they need this one. What they have asked, what they have given, you have to equate both. So I'm going to equate number of moles with stoichiometric coefficient of nitrogen, that is given, number of moles with stoichiometric coefficient of ammonia, that is what they are asking us. Now can I find out the number of moles of N2? Obviously, N is equal to given mass by molecular mass. Given mass they have given as 28 gram, right? It's 28 gram divided by 28, and what you are gonna get, number of moles as 1. So you got number of moles 1, stoichiometric coefficient is also 1, this time 1, and N of ammonia by stoichiometric coefficient of ammonia is going to be 2. So I have written as 2. So N of ammonia becomes 2. N I know. Molecular mass of ammonia I know. What is the weight of ammonia produced? That is what I have to find out. So N of ammonia already I know. I wanted to find out the weight of ammonia. So N into molecular mass. N is 2, molecular mass of ammonia 17. So you got the 34 gram as the answer. That's it. This is how you have to solve. Look at that. I'll be giving you one more question. 10 gram of calcium carbonate is heated. Find out the weight lost. This is what the question. Find out the weight lost. Okay. How many grams of calcium carbonate is undergoing decomposition? 10 gram. So calcium carbonate upon heating, what happens? It will be converted into calcium oxide plus CO2 gas. CO2 is a gas. What it will do? It will escape. Then what is remaining? Calcium oxide. That is what we are calling as residue. Residue. This question can be asked in two ways. Either they can ask you, what is the mass lost? Mass loss means the amount of gas that have produced, because if the gas is the product, gas can escape, right? So gas will be lost. That is what the meaning of this question. If you heat 10 gram of calcium carbonate, find out the weight lost. The carbon dioxide escaped. That is what the weight lost. So how much carbon dioxide is formed? That is what you have to find out. Just remember, from this question you got clarity now. You are heating calcium carbonate. What is the weight lost? We have to find out carbon dioxide gas. If they are asking the question, what is the residue left? What do you have to calculate? You have to calculate the amount of CaO, because CO2 left. CO2 left. What is CO2 lost? What is left? CaO left. This is already a balanced equation. So they are giving us this one. They are asking this one. So N of CaCO3 by stoichiometric coefficient 1 the, and here N of CO2 by stoichiometric coefficient of 1. N of CaCO3 given mass by molecular mass 10 by 100, so it's going to be 1 by 10. 1 by 10 becomes N of CO2. Now weight of CO2 is N into molecular mass, so 1 by 10 into molecular mass of CO2 44. The answer is 4.4 grams. That's it. This is how you have to find out the answers for your questions. Now we'll find out few different types of models of questions. Like when we have to find out the mass relationship, they have given the mass, they are asking the mass. That is how we have done this one. Again, one more example I will do. How much iron can be theoretically obtained by the reduction of 1 kilogram of Fe2O3? So 1 kilogram of Fe2O3 undergoes reduction, reacting with hydrogen. What you are going to get? Fe plus H2O. They have given you the balanced equation already. Writing the balanced equation for the reaction like this one, you wanted to find out what is the mass of iron lost. Let's find out. What they have given? They have given Fe2O3. Fine. 1 kilogram of Fe2O3, I can convert that into 1000 gram. Fine. Fe2O3 is given. Fe they are asking. N of Fe2O3 by stoichiometric coefficient is equal to N by stoichiometric coefficient of Fe. They have given this one. They are asking this one. So we are equating these together. And I wanted to find out the number of moles of Fe2O3. So given mass is 1000 gram by molecular mass Fe 56 into 2 112 plus 48, that's gonna be 160. So 1000 by 160 will be the number of moles of Fe2O3. So number of moles of Fe2O3 I'm substituting here by 160 into stoichiometric coefficient is 1. That's okay. Then number of moles of Fe is what? The unknown. Stoichiometric coefficient of Fe is 2. Fine. So N of Fe is gonna be 1000 by 160 into 2. What I needed the how much, the amount of iron produced. So weight of iron is what I am going to find out. It is N into molecular mass. So let's find out that 1000 by 160 into 2 is N, into 56 is the molecular mass of iron. So we can cancel this one. How we are going to cancel? Look at this. This can be gone. 2, 8 times 8, 7 times. You got the answer. Weight of Fe. How much is the weight of Fe? 7 into 100, 700 grams. How easy it is. This is how you have to solve this type of mass relationship question. Then this is another question, you can try it by yourself. Okay, fine. Now next question, type 2 mass volume relationship. Fine. What they have given. For complete combustion of 3 gram of ethane, find the required moles of O2 and formed moles of CO2 and find out the volume of O2 and CO2 at STP. They are asking us what is the volume at STP2. Okay, I'll do one thing. I'll be finding out the moles of O2 as well as the volume of O2 at STP. For carbon dioxide, you can find out the same way how I proceed. Who is undergoing combustion? 3 gram of ethane is undergoing combustion. 3 gram of ethane. Ethane is a hydrocarbon. Let's make the combustion of this one. C2H6 plus O2 gives you CO2 plus H2O. This is how the combustion reaction will work. Now, if it is a combustion reaction, always the product is going to be carbon dioxide and water. And how you have to balance a combustion reaction. First, balance carbon. Second, balance hydrogen. Third, balance the oxygen. Now, first I'm gonna balance the carbon. How many carbon atoms are there? You got two carbon atoms on the left hand side, so it is two. Then hydrogen, here six, here two, three. Now how much oxygen is present? Left only two, right? 2 into 2, 4, 4 plus 3, 7. So this is going to be 7 by 2, right? So now moles of O2 I have to find out. They have given 3 gram of ethane. So they have given, they are asking. So N by stoichiometric coefficient of ethane is equal to N by stoichiometric coefficient of oxygen. N by stoichiometric coefficient of ethane, ethane 3 gram, N is equal to given mass by molecular mass. Given mass is 3, molecular mass of ethane, C2 is 24 and hydrogen is 6, so it's going to be 1 by 10. So stoichiometric coefficient is 1, so it's okay, 1 by 10. And here number of moles of O2 I don't know, and here it's 7 by 2. So what I can write as N of O2 is equal to, the 7 by 2 will go on to the other side, so 7 by 2 into 10. What I needed the number of moles of O2. This is the number of moles of O2, 7 by 20. Fine. Now, what I needed, volume of O2 at STP. At STP condition, how we will be finding out the volume? N is equal to volume by 22.4. So, volume is equal to N into 22.4. What is N? N I have found out, 7 by 20 into 22.4. This can be cancelled. This can be written as 11.2. So 11.2 into 7. I'll multiply 784 and it is 11.2, so it is 78.4. 78.4 divided by 10. So the answer is 7.84 liters. So what is the volume? What is the volume? You got the answer. It's 7.84 liters. So volume of O2 is 7.84 liters. Number of moles of O2 is 7 by 20. You can solve it like that. So if they are giving mass and they are asking of the volume, mostly they will be asking the volume at STP. So equation of volume at STP is N is equal to V by 22.4. Don't forget that. Now there is another question. They have given 10 gram of hydrogen react with nitrogen. What is the volume of NH3 at STP? Volume at STP. So volume by 22.4 is equal to N. Volume of STP, how you will be finding out? N into 22.4. Find out N from here. Then proceed. They have given hydrogen. They are asking about ammonia. Equate these both. Which is the reaction? Here goes the reaction. Fine. Now next one is volume relationship. They have given the volume, they are asking the volume. Let's find out this one. For complete combustion of 1.12 liters of butane, the produced volume of H2O and CO2 at STP. Again here we'll find out STP it is for complete combustion of butane. Let's again it's a hydrocarbon. Let's go with the combustion reaction. C4H10. What are the hydrocarbon? If it undergoes combustion, you are going to get carbon dioxide and water. That's it. C4 balance, we can balance this. C4 4CO. Hydrogen 10, here hydrogen only 2, so 5 into 2 10. Then oxygen, here 4 into 2 8, 8 plus 5 13, 5 8 13. So this is going to be 13 by 2. Now what I have to find out, it's volume. I actually, if it is volume, we can directly equate the volume, right? So here 1 moles of C4H10 is reacting with 13 by 2 of oxygen, is giving you 4 carbon dioxide. So they are asking the carbon dioxide as well as H2O. First I'll go with the carbon dioxide, then we can find out the H2O. So from butane I have to know what is the amount of carbon dioxide formed. So I can write N by stoichiometric coefficient of C4H10 is equal to N by stoichiometric coefficient of CO2, and N of C4H10, that they have given the volume, right? N is equal to V by 22.4. V is 1.12 by 22.4. 1.12 I am going to write as 11.2 into 10 power minus 1 by 22.4. So this is going to be 0.5 into 10 power minus 1. That is 0.05. You got that. So here stoichiometric coefficient is already 1. So 0.05 divided by 1. So it's going to be N of CO2 by stoichiometric coefficient of CO2 is 4 is equal to N of butane, that is 0.05, by stoichiometric coefficient, it's 1. So what I needed the volume of CO2. So N of CO2 is equal to 4 into 5. That's 4 into 5 is 20, right? So 20 into, I can write it as 5 into 10 power minus 2. So it's going to be easy. 5 into 10 power minus 2 into 4 is 20 into 10 power minus 2. So now what I have to find out? I have to find out the volume. Volume is equal to, because they are asking the volume of carbon dioxide formed. So volume is equal to N into 22.4. So it's gonna be 20 into 22.4 into 10 power minus 2. So I can say that this 0 cancelled. So this is 10 power minus 1. 22.4 into 2, 44.8 into 10 power minus 1. That's going to be 4.48 liters. So if 1.12 liters of butane burns, you will be getting 4.48 liters of butane. This is again simple, because I told you we can equate this with respect to volume directly. So if you make the reaction of 1 liter butane, and you are getting 4 liters of carbon dioxide. If you are gonna use 1.12 liters, then what is gonna get? 4 into 1.12. 1.12 into 4, what's gonna happen? Look at that. 1.12 into 4. 4.48 liters. You can finish this very easily, right? Because volume, moles and molecules you can directly equate. So 1 liter gives you 4 liter. So 1.12 liters give you 4.48 liters. You don't have to do this much. Okay, I hope you understood this one. You find out the CO2 in CO2 is what you have found out. You go for the H2O. H2O, if you wonder, okay, if H2O will be solved, look at that. Again the equation I have to write again. C4H10 plus, I think it was 13 by 2 O2, gives you how many CO2? 5 CO2, right? Sorry, 4 CO2. 4 CO2 plus 5 H2O, right? Yes, it was right. Now 1 liter of butane is giving you 5 liters of water. So 1.12 liters of butane will give you 5 into 1.12 liters of water. That is easy, right? 1.12 into 5, 5.6 liters. So you are gonna get 5.6 liters of H2O. This is how you have to solve it simply, because it's volume we can directly equate. Just remember one thing, the weight is the only thing that we cannot equate directly from the stoichiometric coefficient. And also you can try this one, find out the answer for this one. That's it. So you try to figure the answer for this one. That's it for the session. We'll be meeting in the next lecture. That's it. Thank you.